For years, the world of AI hardware has been dominated by a handful of tech giants, with their GPUs powering everything from chatbots to self-driving cars. But now, a quiet revolution is taking place in Europe. VSORA, a French semiconductor company near Paris, has introduced the Jotunn 8, a groundbreaking AI inference chip. Named after the giants of Norse mythology, Jotunn 8 is not just another chip vying for attention. It represents a fundamental reimagining of how AI inference should work. Instead of chasing raw computational power alone, VSORA has focused on three pillars: exceptional performance, radical efficiency, and unprecedented accessibility. This marks a turning point in the AI hardware landscape, promising to democratize access and break the monopoly that has long defined the industry. NVIDIA has long set the standard in AI hardware, capturing over 80% of the accelerator market. Their GPUs are powerful, but this dominance has led to several systemic challenges. High costs, immense power consumption, and vendor lock-in have become the norm. Smaller organizations, research institutions, and emerging markets often find themselves locked out due to the prohibitive expense of enterprise-grade GPU clusters. Meanwhile, the energy demands of traditional AI accelerators have raised sustainability concerns, and the reliance on proprietary software ecosystems limits flexibility. The industry has accepted these barriers as inevitable until now. The arrival of Jotunn 8 signals a shift, offering a credible alternative that challenges the status quo and opens the door to broader innovation. The concentration of AI hardware innovation in just a few companies has far-reaching consequences. Supply chain vulnerabilities become systemic risks, and geopolitical tensions can threaten hardware availability. High prices persist due to limited competition, and innovation is stifled when only a few approaches are allowed to flourish. Europe has recognized the strategic importance of developing its own AI hardware capabilities. The European Chips Act, with billions in funding, aims to strengthen semiconductor manufacturing and design. VSORA's Jotunn 8 fits perfectly into this vision, representing a step toward technological independence and industrial competitiveness for Europe. The Jotunn 8 is not just another AI accelerator. At its core, it embodies a philosophy that AI inference doesn't need brute force. It needs an intelligent balance between memory, bandwidth, compute, and control. VSORA engineered the Jotunn 8 using a sophisticated chiplet architecture. Each of the 8 chiplets contains 2 dedicated compute engines, large on-die SRAM memory blocks, dedicated HBM controllers, and an embedded RISC-V processor subsystem. These chiplets are packaged together using advanced CoWoS technology, connecting each compute chiplet directly to its own high-bandwidth memory module. This design delivers massive bandwidth and eliminates traditional data movement bottlenecks, setting a new standard for AI hardware. One of the most significant innovations in the Jotunn 8 is its near-memory computing architecture. Traditional AI accelerators constantly shuttle data between external memory and compute units, wasting time and energy. VSORA's approach brings computation as close to memory as physically possible. The large on-chip SRAM acts like a lightning-fast register file, feeding the compute engines at multi-terabyte per second speeds while consuming far less power. Proprietary data mapping algorithms ensure zero access conflicts, maximizing data reuse and minimizing expensive external memory accesses. This is a fundamental rethinking of the memory hierarchy, not just an incremental improvement. Let's break down the technical specifications that make the Jotunn 8 stand out. It delivers 3,200 teraflops in FP8 dense operations and supports multiple precision formats for different model types. The chip is algorithm-agnostic, meaning it doesn't lock users into specific frameworks. Its memory subsystem boasts 288 gigabytes of HBM3E capacity across 8 chiplets, with an incredible 8 terabytes per second local throughput. The 3-tier memory hierarchy HBM3E, on-die SRAM, DCM, and register files ensures efficient data access. For scalability, PCIe Gen 5 enables high-bandwidth, low-latency connections between multiple accelerators without the need for proprietary interconnects. All this comes with significantly lower power consumption compared to traditional GPU-based inference. A key differentiator for the Jotunn 8 is its fully programmable algorithm-agnostic architecture. Unlike many competitors, users aren't confined to a specific software ecosystem or proprietary stack. The chip supports host processor agnostic operation, works with various CPU architectures, and is based on the open RISC-V instruction set for maximum flexibility. It's designed to integrate with mainstream AI development tools, allowing developers to fine-tune performance for their specific workloads. This openness stands in stark contrast to the walled gardens of current AI hardware, giving developers, researchers, and enterprises the freedom to choose the best tools for their needs. While VSORA has been cautious about releasing detailed benchmark comparisons, the Jotunn 8 specifications and architecture suggest it can challenge incumbent solutions across key metrics. Its near-memory architecture dramatically reduces latency, making it ideal for real-time AI applications like chatbots, fraud detection, and search engines. The massive 288 gigabytes of HBM, 3E memory, and sophisticated memory hierarchy mean even the largest models can be served with minimal latency penalties. For batch inference workloads, the 3,200 TFLOPS of compute performance and 8 terabytes per second of memory bandwidth ensure that neither compute nor memory becomes a bottleneck. The chiplet design also enables excellent scaling for enterprise-level workloads. VSORA positions the Jotunn 8 as a cost-efficient alternative to existing solutions. While specific pricing is yet to be announced, the focus is on delivering more speed for the budget. Lower power consumption translates directly into operational cost savings, especially in large data centers running inference 24/7. Over time, electricity costs can rival or even exceed hardware acquisition costs. By consuming significantly less power, the Jotunn 8 offers a compelling total cost of ownership advantage. This makes AI inference more economically viable for a broader range of applications, from startups to large enterprises. Energy efficiency is not just about saving money, it's about sustainability and environmental responsibility. As AI's energy footprint grows, both operators and regulators are paying closer attention. The Jotunn 8's near-memory architecture fundamentally reduces the energy wasted on data movement. By keeping data close to computation and maximizing reuse of cached data, the chip achieves better performance per watt. This benefits both the bottom line and the planet, aligning with Europe's broader goals for sustainability and responsible technology development. The emergence of VSORA and the Jotunn 8 is closely tied to Europe's strategic push for technological sovereignty. The European Chips Act, with €43 billion in investments, aims to double Europe's global market share in semiconductor production by 2030. VSORA, as a homegrown company designing cutting-edge AI accelerators, embodies the innovation the Chips Act seeks to stimulate. By building its own capabilities, Europe reduces dependence on foreign suppliers and strengthens its position in the global technology landscape. Recent years have highlighted the fragility of global semiconductor supply chains. Trade tensions, pandemics, and geopolitical conflicts have all created volatility in chip availability. For European companies deploying AI systems, this creates strategic risk. Having European-designed and manufactured AI hardware provides resilience. If access to certain foreign technologies becomes restricted, alternative supply chains exist. This is not just about competition, it's about ensuring that critical infrastructure remains accessible and reliable, no matter what global challenges arise. Even the most impressive hardware can fail without robust software support. For the Jotunn 8 to achieve its potential, VSORA must deliver a complete software stack that makes the chip accessible to developers and easy to integrate into existing workflows. This means supporting popular frameworks like PyTorch and TensorFlow, providing tools for performance optimization, and ensuring smooth migration from other platforms. Open standards, clear documentation, and strong partnerships with the open-source community will be essential for building a thriving ecosystem. Despite its promise, the Jotunn 8 faces significant challenges. Building a mature software ecosystem takes time and resources. Developers are accustomed to established workflows, and migration must be smooth and beneficial. Manufacturing at scale is another hurdle. Securing sufficient capacity and maintaining high yields is notoriously difficult. Market incumbents like NVIDIA and AMD will not stand still. They have the resources to innovate and protect their market share. Finally, pricing strategy will be critical. The Jotunn 8 must strike the right balance between affordability and sustainability to achieve its democratization goals. VSORA announced that the Jotunn 8 entered production in October 2025, with full volume manufacturing expected in Q1 2026. Early access will likely go to strategic partners and pilot customers. Pricing details are forthcoming, but the company's emphasis on cost efficiency suggests competitive rates. Enterprises planning deployments will need to consider not just unit pricing, but also total cost of ownership, including power consumption and software support. As a European company, VSORA may initially focus on European customers before expanding globally, building support infrastructure and partnerships along the way. The VSORA Jotunn 8 arrives at a pivotal moment in AI development. As artificial intelligence becomes essential infrastructure, the hardware powering it grows ever more important. For too long, the AI accelerator market has been defined by limited competition, high costs, and vendor lock-in. The Jotunn 8 challenges this status quo with its chiplet architecture, near-memory computing, and commitment to openness and efficiency. By delivering 3,200 TFLOPS of performance, 288 gigabytes of HBM3E memory, and 8 terabytes per second of bandwidth in a power-efficient package, VSORA has created a chip that could truly democratize AI inference and set a new standard for the industry.